Infix, postfix, and prefix are three different methods of representing mathematical expressions. In case of infix expression, the operator is placed in between the operands. For example, if A and B are two operands, then we put the operator between these two operands. In case of postfix expressions, the operator is placed after the operands. For example, A plus B is represented as AB plus. On the other hand, in case of prefix expressions, the operator is placed before the operands. It is the same. A plus B is represented in prefix notation as plus AB. The question is, why do we need these three types of expression? Although infix is the most widely used method of presenting expressions or mathematical statements, however, it has a lot of disadvantages. For example, the infix expression demands the knowledge of operator precedence rules in order to evaluate it. It also required the associativity rules among operators, and mostly the parentheses are used to control the order of operation evaluation. On the other hand, the postfix and prefix expression evaluation process are easier compared to infix expression, because in programming language, to evaluate infix or postfix expression, we do not have to have the knowledge of operator precedence, nor we should have the requirement of associativity rules. It also does not include any parentheses to represent or express the order of operation evaluations. So the programmers, based on the approaches given by mathematicians, they prefer to write an expression in prefix or postfix format only. So it makes parsing easier and eliminates the ambiguity in evaluation. In this video, we will discuss the process of converting an infix expression into postfix expression. For that, first of all, we will see an algorithm, and that algorithm will convert a given infix expression into its postfix representation. We will also see some examples to convert one form to another, mainly infix to postfix. Problem of converting infix into postfix expression is one of the problem where we can make use of a stack data structure. This problem will mainly focusing on the process of using a stack in solving real problems. In the process of converting infix expression into postfix expression, we take an input and we put it to the algorithm or the process that converts the infix into postfix, and the output we get is a postfix expression. We give input as infix expression. The algorithm processes the given input and then it converts the given infix expression into postfix expression. For example, if I give one input expression as A multiplied by B, the algorithm will process this input expression, and after processing it will give us one statement which is in postfix expression. Input given to the process is can be considered as array of characters, or a string with the restriction that the input string comprises of either operands like a, b till g, and it can have some valid operators plus, minus, star, and all other valid operations or valid operators that can be possible to use in any expression. And also it can have opening bracket and closing bracket. Apart from these three things, no other elements or characters may present. Similarly, the output is also a string or array of characters. The string will contain various operands given in the input string like a, b till g, and apart from that it can also contains the valid operators in the programming language, available in the programming language, but it cannot have the opening and closing curly brackets, because the main purpose of using the postfix expression is to avoid the use of brackets in order to determine the precedence or determine the priority of various operators. So apart from the input and output, it uses a linear data structure called stack. So based on the input provided, we produce the output. Input is in infix expression or infix form. Output is in postfix form. During the process of conversion, the algorithm make use of a stack. So next we will see the algorithm to convert infix into postfix form. This algorithm is for converting infix expression into postfix expression. The input string here is the expression in infix format. For example, a plus b multiplied by c minus d. This is the expression, and this is known as input expression, which is in prefix. And the algorithm has one output. That output is also another string which give you the input expression in postfix notation. So it will look like c star d minus, because this expression will be executed first, after that this expression, finally this will be completed. So if I do this, plus will go after b, star will go after c, minus will go after d. So this is the postfix expression for the given infix expression. That's what is done by this algorithm. And this algorithm, in order to convert, this is the process of conversion. In order to convert the infix into postfix, it takes a stack in order to complete the conversion, right? In order to do the conversion, it makes use of a stack. We'll use push and pop function along with the empty stack checking within the push and pop functions. So it has basically two parts. Whatever we have in the infix expression, these are called symbols. We consider these are symbols. In the input expression, we can have only these three things. First is it can have operands, it can have operators, and it can have opening and closing brackets. It means that we cannot have one symbol like this. We cannot have some symbol this in the infix because these are not considered as a valid operator. Then the output string will have only operands, valid operands and valid operators. It will not have any opening bracket or closing bracket because the postfix expression does not contain any such expressions. As per the algorithm, we have to scan the string, we have to scan the array of characters here. If it is an operand, we need to add directly to the output string, and otherwise if it is any one of this, either it is a operator or it is opening or closing bracket, in that case what we have to do, we have to perform this block. So if it is not an operand, then it will go to the else part. In the else part again, we will check for several conditions. First of all, we will check if the stack is empty or the incoming signal is a left parenthesis. And here we will make use of the function empty, which is defined in the stack. Then if any one of the condition is true here, we will push that symbol. Otherwise, if it is not an operator, it can be a closing bracket. If it is a closing bracket, what we will do, we will pop all the elements. We will append the popped element in the output string, and then we will remove the opening bracket from the stack. Suppose that we have scanned a symbol which is a operator, say multiplication operator. When we read a symbol which is an operator, then we compare the precedence of incoming operator or the symbol with the top of the stack. Since the top of the stack also contains one operator, we will compare that operator's precedence with the precedence of the incoming operator. If the precedence of the current operator is higher than that of the existing symbol in the stack, then we will push this operator into the output string. Otherwise, suppose we have scanned the operator plus and the stack contains an operator which is multiplication. We'll compare the current operator with the precedence of the existing operator in the stack star. We found that the existing operator's precedence is higher than that of the precedence of the current operator. In that case, we'll pop this element, we will pop this operator, and we will put it in the output string, and then we will push the current symbol, which is a plus, in the top of the stack. So this is a condition where we scan an operator. Then finally, put string, we reached at the null character. That means this is the end of the string. If this condition occurs, simply we will pop all the elements star, we'll put it at the end of the output string, we'll pop this one, we'll put it here, and if it is empty, then we will end up the program. Okay, if we follow this algorithm, then finally whatever the content of the output string will be in postfix expression. Then we can print this postfix expression from the output string given here. This is postfix. We use one variable j to use as a index for the postfix, and we use one index I for the infix expression. We also have a stack. This stack is used as a data structure to convert infix into postfix expression. Is top of stack. This is the stack. This is j. This is I. And let us say we have entered one expression starting with opening bracket, then a plus b, then close this, and we have null character. This is the input string. We have to convert this input string into this postfix expression that will be stored in this array. What I will do, first I have one while loop. In the while loop we will scan, this is value of I is equals to 0. So I have one more variable symbol. Symbol will take the first element identified by I. This one is, say for example, here it is opening curly bracket. Then when we have one symbol in this variable, we go to the algorithm. What it does, when it gets one opening bracket as a symbol, it will simply push this one here. It will be pushed into the stack. What it will do, it will put it here. Push operation we will apply. Push operation. Push the symbol is the opening bracket, so it will push here, then immediately it will be 1. At the same time it will be also incremented by 1. Then after that I will continue the scanning of the input statement. Now the symbol will be a. Since the symbol is a, which is considered as an operand, so simply we'll put this a in the postfix expression. At the same time this 0 will be incremented to 1. It will be repeated, so I will read this. Now this symbol is plus. If it is plus, that means it is not an operand, that is an operator. Okay, this plus is an operator. What I will do, I will now refer to the stack. As per the algorithm, I will refer to the stack and I will see what is the content of the stack. At this point, top of the stack is this opening bracket. So that's why if it is opening bracket, that means it is not an operator which is in the stack. So simply I will push the element. The symbol here? Symbol here is plus. Same time it will be incremented to 2. Then I will increment this one to 3. I will be incremented to 3. But this time I am not increasing the value of j. Then I will be reading the next symbol, which is equals to b. It is an operand. So if it is an operand, put that one in the postfix string and I will increment it to 2. Okay, then I will increment now I to 4. 4 means here now I am here. This symbol if is I get one closing bracket in the input string, then go to the stack and pop all the elements x till curly bracket. That means I have to pop it. Once I pop, so since this is the one, this is the symbol, so I will pop the stack, then I will put x. X means this time it will come plus. I will put plus here. Then again I will pop opening bracket. I will pop it. If I pop, it will be 1. If I pop this, it will be 0. And I will pop both, but since I have added plus here, so it will be incremented to 3. But this one I will not put I will not put in the postfix expression. I'll simply ignore. Then I will repeat this. It will be incremented by 1. It will be incremented by 1. This is 5. At that point of time, this is the null. This is null. Symbol is equals to null, so it will exit the while loop. After exiting the while loop, what function we do? Simply I go to the stack, but at this point you can see we do not have anything in the stack. This has been popped. This is also popped. Top of stack equals to 0. Right? If I go to stack, then the stack is empty. If stack is empty, then this one is the postfix expression. The infix expression was A plus B. This was the infix expression with brackets, and if it is converted to postfix, then I will read this string A B plus. Now let us take one more example. In this time what I will do, let me take one more element here. So this is multiplication, then we have another symbol C, we have the null character here. This is I, this is J. Initially this is 0, this is also 0. Stack, this is top of stack, top of stack. POS, top of stack is also 0, right? Then we will evaluate this. First, I0 will start the while loop, means we will start scanning this string, given string. Symbol equals to symbol is equals to opening bracket. So since it is opening bracket, we will put it here. We'll increment this to 1. Then I will increment this one to 1. Then I will read A. This is now A. If it is A, since it is an operand, so we will put it in the postfix. I will increment this one by 1. I will also increment this one by 1. I will read plus symbol here. This is plus, this is an operator. Since it is an operator, so I will put it here. But here I need to check the condition. Is the top of the stack comprises of any operator? If it is an operator and has higher precedence over the new one, then we have to replace them. We have to pop the higher precedence operator and push the new one and push again the higher precedence operator. But that is not the condition. Here on the top of the stack we have only opening bracket, so I will simply push the operator here. If I push, then it will be now 2. Then this one will be incremented at the end of the while loop. Then I will read this element. This element is now B. B is an operand. I'll put B here. Then I will increment this to 4. Then I will have this bracket, closing bracket. If I have a closing bracket, then I will remove all the elements from the stack. First I will remove plus. I will put it here. Increment this by 1. Then again I will, if I pop this, it will be 1. Again I will pop another element, this bracket, but however I will not put the bracket here, so it will be 0 and I will ignore the opening bracket. And then I will increment this by 1. It is 5 now. If it is 5, then I will read this element. This is star. Then since it is an operator, I will check the stack, I can see here this is 0, so this stack is empty. If it is empty, simply I'll push that star here on the top of the stack. It will be now 1. Then I will increment this value to the next element, that is 6. I will read this C. This C is an operand, so I will put it here, and I will increment it by 1, 3. Then I will increment it by 1, 7. At that point of time, I am here. It is end of the string. So if it is end of the string, I will go to the stack. I'll go to the stack. This is now is the symbol. I'll go to the stack. I can see I have one element because top of stack is not 0. Okay, this star I will pop and I will put it in this postfix string. So I'll increment it to 4. Okay, and it will be decremented to 0. So I need to pop all the elements till the stack is empty. Now stack is empty. So resultant string I can get it from this array. So input string was bracket A plus B multiplied by C, and first this one will be evaluated, so it becomes AB plus, then this operation will be performed, so C star. This should be the postfix expression. Now if I go here AB plus, if I go here A B plus C star, and this is exactly what we should have.